Hello, welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. This is going to be our last video talking about for loops, at least the basics of for loops. We're obviously going to see for loops a lot. We're going to see all of these loops a lot as we continue to move forward, as all of our knowledge continues to stack up. And in this video, I want to talk primarily about how we can put multiple generators inside of for loops. We'll also look a little bit at the patterns and then some other of the syntax options. So if we go back to our simple counting example that we had originally for I in 1 to 10, print line I. Well, what if I wanted to print something kind of like a multiplication table where I wanted to print out all ij pairs where I and j both run from 1 to 10. Well, one way to do this would be to put nested for loops. And in most languages, that's exactly what you do. In Scala, you have the option of adding another generator inside of here. And so then I can print I plus times j equals something like that. And you'll notice that this prints out a lot of stuff. Okay? The way that this works is that this generator, the first value, 1, goes into I. And for that one value of I, j runs through all the possibilities. So I was 1, j went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we printed out basically all the multiples of 1 there. After j is completed, it goes back and I becomes 2. And then j runs through all the possibilities. And I becomes 3. And j runs through all the possibilities. So the number of things the number of times this loop occurs is multiplicative. So the inner one happens 10 times and the outer one happens 10 times. And that's not a total of 20. It's not additive. It's multiplicative. So the whole thing happens 100 times to print out this whole multiplication table. Now, something to note about this: what if instead of printing, I wanted to yield some tuples with the multiplication facts inside of them? So I want to yield I, j, and the product of I and j. This is one difference between having a single for loop with multiple generators and nested for loops. In fact, we could write this again using nested for loops. And I will put it all on one line. Hopefully you'll be able to tell what this is doing. So this is for I goes to 1 to 10, and inside of each one of those yield the result of for j goes from 1 to 10, and that yields ij I times j. Okay. Our first example here just gave us a single vector of 3 tuples. Okay. So it's a single vector that runs through all 100 possibilities. This gives us not a single vector that runs through all 100, but a vector of vectors. And each one of these interior vectors has 10 values in it, and then there are 10 values in the outer vector, each of which is a vector of 10. So we still have 100 elements here, but they're structured a little bit differently. In fact, this is more like a two-dimensional vector, and we'll come back and talk about those in the next video. So this syntax with multiple generators is not quite the same as actually nesting the loops, at least when it comes to having a yield in there. You always get a single, basically a flat collection when you use yield with multiple generators. The value that we have in here, so let's say I didn't want to do the entire table, I just wanted to do kind of the upper half of it. Well, that works just as well too. The value of j can depend upon I. Now if you start putting in, so we've seen the fact that you can put in now multiple generators, you can have variable declarations, you can have if guards. There are lots of things that you're allowed to put inside of the main body, or inside of the the parentheses of a for loop. And so far I've been putting them all in one line and separated by semicolons. Turns out that if you have a lot of them, this is actually not the recommended style. Instead, the recommended style is to switch from parentheses to curly braces, and to break it across multiple lines. J in I to 10, close the curly brace, yield I comma j comma I times j. Okay. Same result. If you do the curly braces, you're allowed to break things across multiple lines and you don't have to put semicolons. And so this way you can put a generator, and then if you have variable declarations or if guards or whatnot, you can do that. Let's go back to this to demonstrate that. Let's say I only wanted the values where I is even. But then I want to run through there. So you'll note that I do not have 1, 1, 1 here. My first element is 2, 2, 4, because this if guard prevents us from doing any of these when I is odd. Okay, so this shows you how you can combine all of these different elements that we can put in here. The curly brace syntax for when you have a lot of them together. Now, I'm showing you all of this, though the reality is that most of the time when you use a for loop, you're going to use it somewhere close to the very basic syntax. You're probably going to have one generator, you might have one if guard, you probably don't have any vals, and there's a good chance you'll be using yield in there. One last thing that I want to demonstrate, and so we saw how our for loops could use patterns. This was with our point and the fact that we could pull out x and our y instead of having to use the weird tuple syntax or to assign it in a value and pull out the values from the patterns. Now, to demonstrate this at this point, I'm going to create something that's kind of an odd entity. I'm going to make a list that has some weird stuff in it. Okay. Now, this is weird. It winds up being a list of any. Later on, we'll have better examples to motivate this. But at least for now, I have a list with a bunch of different stuff in it. So what happens if I run through this list and I put these values into a tuple, into a pattern that only matches tuples? Well, that's not going to match 1. Okay. And if we do something, so I guess before showing you, what happens if I take a val and I try to do a comma b and set it equal to the head of this list? Well, I get an error. Now, if I were to take it and set it equal not to the first element but to the second element, it works just fine. Okay? If you try to match a pattern to something that does not match it, and you get a match error. And that really causes us problems for val. This is why if you use the match statement, you need to have a case that covers every possibility, because if you get something and it's not it's a possibility you didn't cover, you're going to get one of these errors. So what happens in a for loop? Well, so in some ways I've shown you two possibilities here. One is that this is going to cause an error, or two, it's somehow going to do something else. Oh, and I can't do, let's just make a tuple. Okay. And you can see what this did, it didn't crash. Okay. Even though the value mixed, has a bunch of stuff in here that does not fit the pattern A to B, that wasn't a problem. And this is one of the wonderful things about for loops. And as I said, later on we will see more examples, especially in like the second half of the book, of how this can be extremely useful to you. To put in a pattern here, and if there are things that don't fit it, it's just like they're skipped. It's just like there's an if guard and they are ignored. And only the things that fit that pattern wind up being run through, whether it is just, you have side effects, or whether it's a yield or whatever. Only the things that match that pattern will actually be processed. And that is a wonderful thing syntactically, because you might have noticed at this point that this looks a lot like what would happen with a map. If you use a for and a yield, it kind of acts in the same way that a map would. But if you do this with a map, it doesn't automatically match patterns, and it definitely does not automatically skip things that don't match the patterns. So the for loop makes it much easier to do that type of thing. So that's it for this video, and in the next video we'll go back and we'll talk about what happens